In this video, we are looking at calculations in motion. The last video, we described motion and stated some of the equations of motion we will use to solve in this video. We're going to still run down the equations of motion in this video because we are using them to solve immediately. So the equations, number one, we have S equals U plus V over 2, alright, times time. That's one of the equations of motion. Number two, we have V equals U plus AT. That's the second equation. And then the third one, we have V square equals U square plus 2AS. And then finally, the fourth equation of motion is S equals UT plus half AT square. So these are the four equations of motion that we're going to use to solve questions. U represent initial velocity, right? V represent final velocity. A represent acceleration, okay? T represent time. Anywhere we'll see T in the equation, it means time. And then finally, X represent distance, okay? Represent distance. So let's begin the calculation. Example 1. If a car travels 450 meters in 25 seconds, calculate the average speed. If you remember, average speed is total distance divided by total time. First, we are going to state our parameters. Solution. S is given to us as 450 meters. Okay. T, which is the total time, is given to us as 25 seconds. So to get the average speed will be equals to the total distance S over the time. So we'll just do substitution, divide by 25. That gives us the average speed as 18 meters per second. So average speed V equals 18 meters per second. Let's go to the next question. Example 2. A train starts from rest and travels with a uniform acceleration of 0.5 meters per second square for 20 seconds. Calculate its final velocity and distance covered. So we're looking for final velocity and the distance covered. So first, we'll write our solution. We'll bring out our parameters. A train starts from rest. If a body starts from rest in physics, it means that the initial velocity is equals to 0. Okay? If a body starts from rest, initial velocity is equals to 0. Alright, we are given acceleration A as 0.5 meters per second square. Then we are given time T as 20 seconds. And then we are to find the final velocity V, okay? And then the distance covered S. So that's what we're looking for. To know the equation to use to solve this problem, we'll look at the equations of motion that have U, A, T, and V, so we can find the value of V. So check the equations. Which of the equations have U, A, T, and V? So we can substitute these values that we know and find the value we don't know. So if you check the equation critically, the equation that have the 4 parameters is the second one. V equals U plus AT. Okay, so I can find my V. I know U, I know A, and I know T. So substituting my value, V will be equals to U, which is 0, plus A, which is 0.5, okay, times T, which is 20. Okay, so V is equals to 0 plus 0.5 times 20 will give us 10. So V will now be 10 meters per second. Is that okay? Now to find our distance, we can use any of the equations that have distance. Any of them. So let's use the first one. S equals U plus V over 2, right, times time. So U is 0 plus V, which is 10, divided by 2, and then times the time, 20. Okay, so that will give us 0 plus 10 is 10. 10 divided by 2 times 20. 10 divided by 2 is 5 times 20. So we're going to have 100 meters. That's our answer. So any of the equation you use that have distance, you'll be able to get the same answer. Example 3 now. A car starts from rest with an acceleration of 8 meters per second square. Find its velocity when it has covered a distance of 100 meters and the time taken. Okay, so solution. The parameters first, start from rest. U is equal to 0 meters per second. Okay, the acceleration A is equals to 8 meters per second square. The distance covered S is equals to 100 meters. And then we are looking for the velocity, that's the final velocity. We're also looking for the time taken. So which of the equation are we using? We have U, we have A, we have S, and we need to look for V first. But if you check the equation of motion, we're going to be using V square equals U square plus 2AS. Alright, to find V first. So V square equals U, which is 0 square, plus 2 times A, which is 8, then times S, which is 100. So V square equals to 0 square, which is 0, plus 2 times 8 is 16, times this will give us 1600. Alright, okay, so V square will now be equals to 1600. So it means we'll find the square root of 1600. Our answer will be 40 meters per second. Is that okay? 40 meters per second. Alright, to find the time taken, we can use any of the equation of motion that have time. So if we use V equals U plus AT, we can find this T. Okay, V is 40, so 40 equals U, which is 0, plus A, which is 8, T. Okay, 0 plus this is 0, so meaning that 40 will be equals to 8T. Divide both sides by 8. We're going to have 40 over 8 equals 8T over 8. Alright, so therefore T will now be equals to 40 over 8, which is 5 seconds. That becomes our answer. Alright, one more question. The train slows from 108 km per hour with a uniform retardation of 5 meters per second square. How long will it take to reach 18 km per hour, and what is the distance covered during this period? Alright, so solution. Slows from this velocity, so that's my initial velocity, 108 km per hour. We need to convert it to meters per second. So to convert it to meters per second, multiply by 1000, divide by 60 times 60. Alright, this will give us 30 meters per second. Retardation is negative acceleration, so A equals minus 5 meters per second square. Okay, and then the final velocity is given to us as V, 18 km per hour. To convert it, multiply it by 1000, divide by 60 times 60. Okay, that will give us 5 meters per second. Okay, so we are looking for the time, and we're also looking for the distance covered. So to get the time, which of the equation are we going to use? We're going to use, because we have U, we have A, we have V, and we have T. So we're going to use V equals U plus AT to get our time. So V is 5 equals U is 30 plus A is negative 5 times T that we're looking for. Okay, so move this 30 to this side, so 5 minus 30 is equals to minus 5T. Okay, 5 minus 30 will give us minus 25 equals minus 5T. So we'll divide through by 5, divide here by minus 5, we have T, divide here by minus 5, we're going to have T as 5 seconds. That's our answer. Now to find the distance, you use any of the equations that have distance. You can use equation 1 or equation 3 or equation 4, any of them. So we can decide to use any one. V square equals U square plus 2S, or we use just a simple one, S equals U plus V over 2 times time. We're still going to get our answer. Okay, U is 30 plus V is 5 over 2, and then times T, which is 5. Okay, so 30 plus 5 will give us 35 over 2 times 5. Okay, so when you multiply 35 times 5 divided by 2, you are going to get 87.5 as our answers in meters. Don't forget to put your units. All right, that becomes our answer, 87.5. all right, I would like you to do the following exercise from question 1 to 5. Solve it. I'd like to get your feedback on how you resolve the question. Thank you very much for being a part of the class.